So here we're given two vectors. We have vector v in 3 dimensions and vector w here in 3 dimensions, both in their standard unit form. And we are asked to find the dot product v dot w, and then to calculate the angle between vectors v and vector w. So again, I'm going to start here just by converting my vectors to their component form. So I have vector v is v sub 1, v sub 2, v sub 3, and that's minus 1, minus 2, 4. And then vector w will be w sub 1, w sub 2, w sub 3, with components 4, 1, 4. So for part A, we want to compute the dot product. And we are looking for the dot product between vectors v and w. And again, that's going to be the sum of the product of the corresponding components. So v sub 1 times w sub 1 plus v sub 2 times w sub 2 plus v sub 3 times w sub 3. So plugging in our components here, we'll have minus 1 times 4 plus negative 2 times 1 plus 4 times 4. So we have minus 4 minus 2 plus 16, leaving us with 10. So we have a dot product here, v dot w, vector v dot vector w, is equal to positive 10. And then for our second question here, we want to compute or to find the angle. So this is question B. Find the angle between these vectors. And again, we recall that we'll use our geometric interpretation form of the definition here. So recall that vector v dot vector w is equivalently equal to the magnitude of vector v multiplied by the magnitude of vector w multiplied by cosine of theta. So let's go ahead and we'll solve for theta the way that it is written currently. So solving for theta, I'll divide both sides by the magnitude of vector v and the magnitude of vector w, which gives us the dot product of vector v and vector w divided by the magnitude of vector v times the magnitude of vector w is equal to cosine of theta. And then to isolate this theta here, we take the inverse cosine of both sides of this equation, which leave us with inverse cosine of the dot product of vector v and vector w divided by the magnitude of vector v times the magnitude of vector w is equal to theta. So now we have the equation for theta, and we just need to calculate the magnitude of vector v and the magnitude of vector w. So we have the magnitude of vector v is equal to the square root of negative 1 squared plus negative 2 squared plus 4 squared, all under the square root. So that is the square root of 1 plus 4 plus 16, which gives us the square root of 21. And then we have the magnitude of vector w, which is the square root of 4 squared plus 1 squared plus 4 squared, all under that square root. So this is the square root of 16 plus 1 plus 16. So you have 16 plus 1 is 17 plus 16 is 33. And again, looking at our equation here, we know we want the product of those two magnitudes. So we can say that the magnitude of vector v multiplied by the magnitude of vector w is the product of the square root of 21 and the square root of 33. So you could, by all means, multiply these two digits together, 21 times 33, but we know we want to simplify, so let's try to factor this out. We know that 21 is 3 times 7, and that 33 is 3 times 11, so we have two 3's in there. So we can rewrite this as, we've got the square root of 3 squared multiplied by 7 times 11. So the square and the square root will cancel here, leaving us with 3 times the square root of 7 times 11 is 77. All right, so now we are ready to find the angle. We've got our dot product of v and w is equal to 10. We just found that the product of the magnitude of vector v times the magnitude of vector w is 3 times the square root of 77. And so we're ready to plug them in. So theta again is equal to inverse cosine of the dot product of vector v and vector w by the magnitude of vector v times the magnitude of vector w. So this is inverse cosine of 10 divided by 3 times the square root of 77. And if this was a test question, this is where we would leave our answer. We'd box this guy up, and this is in radians. And then if the homework is asking you to round your answer, again, this is when the one of few times you'll be allowed to use your calculator. And so if we substitute this into the calculator, we see that theta is approximately equal to 1.1811. If we're rounding to our tenths place here, we can say that this value is approximately equal to 1.2 radians. And then just be mindful, is it asking for your angle theta in radians, or is it looking for degrees? If it's looking for degrees, you just need to change the mode on your calculator. So theta is going to be approximately equal to 67.674. And again, rounding to the tenths place, we can say that our angle theta here is approximately equal to 67.7 degrees. And again, if this is a test question, this is how I would want you to leave your answer. We'll simplify that radicand all the way, but don't go any further than this.